All right, nomenclature is really just a fancy way of saying naming. So when you're naming chemicals, there's a system for naming them. Now, naming organic compounds, that is a totally different song and dance. Remember, organic compounds are any compounds in which carbon is the central atom. We're going to cover only naming ionic, covalent, and we will do briefly into acids, naming acids. If you want to know how to name organic compounds, I suggest you go to the tab under Unit 12, Organic Compounds, and watch the IUPAC video. This video deals with naming ionic and covalent compounds. So remember that an ionic compound is when a metal gives up electrons to a nonmetal. And a covalent compound is two nonmetals bound together by sharing electrons. And they have different systems of naming. Covalent compounds are the easiest to name. You simply use prefixes to tell you how many of each particular element there are. So if I have a compound like NO2. I have nitrogen and oxygen. How many nitrogens do I have? I have one, so the prefix would be mono. How many oxygens do I have? I have two. The second element always gets the suffix "ide," so we change oxygen to oxide. Man, I'm a little off today. And the first element can receive any prefix with the exception of mono. So we're going to get rid of mono in this case. So this would be nitrogen dioxide. Let's try another one. Let's say I have something like P2O5. I have phosphorus. And I have oxygen. The second element changes its ending to I, so this becomes oxide. How many phosphorus do I have? I have two, so prefix is di. How many oxygens? 5, prefix is penta. Let's leave the A off so we don't have double vowels. And we have diphosphorus pentoxide. So naming covalent compounds, everyone loves naming covalent compounds. When you see non-metal, non-metal, easy as pie. Simply use prefixes to determine how many. Make sure the last element ends in I. Naming ionic compounds is a step-by-step process. And the steps you follow are: first, you name the cation. If the cation is a transition metal, you have to put its charge, because transition metals have various charges or have numerous charges. You have to put its oxidation state or charge in Roman numerals. So, ox state. And you put that Roman numeral in parentheses. Lastly, you name the anion. If it's a single element, just like in covalent compounds, it's going to end in I. If it's a polyatomic ion, one of the ones you memorized over the summer, or one of the ones you are working on memorizing, you simply write its name. So if you have something like CaO, well, that's calcium is the cation, It is not a transition metal because it is a group 2 metal, so that's done. The second element is oxygen. Second element, you change the ending to "ide." So this would be calcium oxide. What if I made it a little more complicated rather than be calcium oxide? Let's say I change it to the thing that makes up seashells. I'm using it today. Again, it's still calcium, but now this is no longer oxygen or oxide. This is carbonate. So this would be calcium carbonate. Let's do one where you have a transition metal. So let's say I have rust. Well, Fe is iron. Iron is a transition metal. It is in the D block. It's in that dip in the center of the periodic table. So I know I'm going to need to put its charge here. The second element is oxygen. But since it's the second one, we change it to oxide. Oxygen's charge, oxygen's oxidation state, is always 2-. So in order for this to be neutral, what charge would have to go here in order to balance it out? So x minus 2 equals 0. Well, this must be a plus 2. So this means that iron is iron 2 plus, so we put that in Roman numerals between the two. So to note that that iron had an oxidation state of 2 plus. The most basic definition of an acid is something that starts with hydrogen, has hydrogen as its cation, and it has some anion. And that anion could be monoatomic, meaning it can be anything like bromine, chlorine, chlorine, or it can be polyatomic, like sulfate or phosphate. When you're naming an acid, you start by naming it exactly how you name ionic compounds. So you name the ionic compound. So let me put up a list of a couple acids. Let's put up a few acids here. Let's say you've got, I'll do the sulfur series because it's the popular one. Everybody likes the sulfur series. So here I have hydrogen bound to various sulfuric compounds. The first one, if you were to name it, you would say that the name of the first one is hydrogen sulfide. Second would be hydrogen sulfate. And this would be hydrogen, one less oxygen than sulfate makes this hydrogen sulfite. If it had 2 less, it'd be hyposulfite, but that's not a real thing. If it had 1 more, it'd be hypersulfate. But we'll go into that in greater detail when I have you in September. For right now, basic understanding of how to name acids is all you really need. Rearrange it so this flows a little bit better. All right, so you name it exactly as you name an ionic compound. Next, you're going to change the suffix based upon what the current suffix is. So let's underline the suffix or the ending of each one of these names. Hydrogen sulfide, last 3 letters are I. So the suffix here is I. Hydrogen sulfate, suffix is 8. So there we go. Hydrogen sulfite, suffix is ite. And that covers actually all the possibilities for suffixes that you'll see in chemistry. So each suffix gets its own change. And I'm going to start with sulfate. I know that it's a little backwards and weird to start in the middle, but I'm starting in the middle because it's the easiest one. So when you have 8, you change 8. 8 goes to, when you have 8, 8 goes to the root of the anion, then ic acid. You completely get rid of hydrogen, and you simply change 8 to ic. So this is going to go away, and this becomes sulfuric acid. So I think I misspelled. That's a U. If you have ite, you change ite to us, O-U-S, acid. And again, hydrogen's going to go away. Change ite to us. So this becomes sulfurous acid. This is sulfurous. And then there's the odd one out. When you have a monoatomic, a binary acid, where it's just hydrogen and one other capital letter, it means it ends in "ide." When you have it ending in "ide," you actually keep part of the hydrogen. Change it to hydro, then the root in acid. So part of the hydrogen stays, you get rid of the gen. Ide changes to ic, so this becomes hydrosulfuric. I'm going to run out of acid. Sorry, I'm going to run out of space. Acid. So the way that I remember these, the way that I remember this little table up here, is I ate icky acid. I don't have a cutesy way to remember ite goes to us. Maybe it's alright by us. I don't know. And lastly, I remember Forrest Gump. And in Forrest Gump, Forrest is obsessed with this girl by the name of Jenny. But Jenny is not a woman of great repute. She gets around a little bit. So if I were Forrest, I'd drop Jen and do icky acid, I guess. You could do it that way. That's weird. That's a strange way to remember it. Probably, please don't turn me up and let your parents listen to this recording. It's odd. But I'd drop Jen, icky acid, is how I remember when it changes from I to hydroic acid. So that's the only time that you keep part of the hydrogen. And all the other times, when it's 8 or ite, we drop the hydrogen completely and we change the suffix. So that is some basic nomenclature. You'll see lots of practice in your summer review packet. If I had you for baby chem, you have done this so many times your head probably hurts just from hearing the word nomenclature. You probably skipped this video. But if I haven't had you before and you need some extra practice, you can use your packet, or even if you Google chemistry nomenclature practice, I guarantee you will come up with so many possible worksheets you could possibly do. So there is that for you. And again, I kind of went over a little bit of this, but the most common polyatomic ions end in 8. If they gain one more oxygen, they become per-8. So the first one that does this that you need to memorize was chlorate. Chlorate can gain one more oxygen, and it becomes even more electronegative and makes it a strong acid if it bonds with the hydrogen. And it becomes perchlorate. which would make perchloric acid. If chlorate loses an oxygen, it becomes chlorite. If it loses another one, it becomes hypochlorite. Notice though that the charge stays the same. All chlorates, or the entire family of chlorates, are 1 minus. Chlorate is the only one that does the full spectrum. The other 3 that you need to memorize only go to ite. Chlorate is the only one that's pretty fair for me to say. However, it is important that you know, the reason you don't need to memorize these down here is because chlorine is in group 17. It is one of the halogens. And actually, any of the halogens can produce similar properties, or have similar properties to chlorine. So you could sub in chlorine for bromine or iodine and have the same effect, or have the same family. So that's why you're not needed to memorize them, because it's just common sense. If chlorine can do it, so can bromine or iodine. Fluorine is a little too small to make all these polyatomic ions. Fluorine is the only halogen that will not do that. While we're in the neighborhood of looking at, put this away. While we're in the neighborhood of looking at some of these polyatomic ions, the other ones that you needed to know don't have family members like that, don't have a series that go with them, such as acetate, carbonate, chromate. Dichromate just means you have 2 chromates, so you have to have a little more oxygen to balance them out. Permanganate, hydroxide, very common. We'll use that when we talk about acids and bases. Cyanide, if cyanide, notice how it ends in I. If you were to name it as an ionic compound and it formed an acid, you'd have hydrocyanide. Well, that would become hydrocyanidec acid. That's a weird one. Peroxide, this is the form of peroxide you'll see. You will almost never see oxygen with a -1 charge, so I wouldn't worry about it too much. And then there's ammonium, it's the only +1. So those are some of the polyatomics, that's some nomenclature. Have a happy summer. Hags.